Hello everyone. This video is for reviewing KSAT math problem. KSAT stands for Korea Scholastic Aptitude Test. This time I want to review the required math problem admission year of 2024, odd type, number 13. This is about geometry, which is related to trigonometric function and its angles. Okay, let me give you several points to this problem first. The first point is the law of sines. Uh, this is a relationship between a triangle, let's call it A, B, and C, and its circumscribed circle here. For instance, let me go directly into the problem. In this case, the length of side line segment BC is square root of 13 here. So I will use the triangle A, B, and C, which is shown on this problem with the same notation and same measure, pi over 3. This is a square root of 13 here. And we can imagine that it has the circumscribed circle here, looks like this. The law of sines say that the ratio between the sine of the angle here and then its opposite side, square root of 13, over its opposite angle, sine of its opposite angle, is always constant. This constant is actually diameter of the circumscribed circle. This is always the diameter. So if we compute this value, since sine of pi over 3 is square root of 3 over 2, square root of 13 over sine of pi over 3 is square root of 13 times 2 over square root of 3. This is the diameter of circumcircle of the circumcircle. Let me go further, dive into the problem here. On this problem, the length of line segment AB is also given as 3, and let's say this angle, the angle ACB, I will denote it as gamma here. And even though we don't know the exact value of gamma, by using this law of sines, because it shares the circumscribed circle here, so the opposite side over sine of its opposite angle gamma is the diameter of the circumscribed circle. The diameter is actually square root of 13 times 2 over square root of 3. So if you arrange this term, you can have the sine value of this angle gamma, which is 3 times square root of 3 over 2 times 1 over square root of 13. Okay. So the first point is the law of sines. The second point is the area of triangle. In this case, for instance, in the case of triangle ABC here, this triangle looks like this, and we do know the length of two sides here, and we do not know the middle angle B, but if we think that square root of 13 is the length of its base, and the height would be 3 times sine of B, capital B. Okay, so the area can be expressed as on this problem we denoted it as S1. The area of the triangle A, B, and C will be 1/2 times the length of its base, square root of 13 times, and height 3 times sine of capital B here. Okay, so actually the area of a triangle is 1/2 times length of two sides times sine of its middle angle here. Likewise, we can express the area of the triangle ACD here. Let's call it S2. Area of ACD, likewise, 1/2 times. I will focus on this middle angle. And then we have to multiply those two sides, AD times CD times sine of D here. And since the value of the length of line segment AD times CD is given as 9 here, this is 9, so the area S sub 2 will be 9 over 2 times sine of capital D here. The third point of this problem is the law of cosines. In this case, I want to focus on the specific case of triangle ABC here, okay, and the length of, AC, not AD, length of side AC here. The law of cosine says the square of length of side AC square equals to sum of square of the other two length of the other two sides minus 2 times length of the other two sides, 3 times square root of 13 times cosine of its opposite angle here, cosine capital B here, 3 times square root of 13. Let me change the color because this is a length of the side and this is a cosine of the opposite angle B here. Opposite angle with respect to the target side AC. This problem requires students to use many properties, many formulas to approach this problem. This is why students may feel extra difficulty to deal this one problem. We need like at least 3 laws. Okay, I'm not give you a full detailed description or computation to get answer. Rather, I want to give you a full big picture for this problem. But I need to be more specific here to give you a detailed, like detailed formulas for each formulas of trigonometries. Okay. Let me move forward. Let me give you a question. How can we find the cosine value of cosine capital B? Cosine capital B. The angle B here, I denoted the angle ACB as a gamma here. Angle B is pi minus pi over 3 plus gamma here. So if you remember the angle sum rules for cosine capital B equals to pi minus pi over 3 plus gamma. And then this is same as minus cosine pi over 3 plus gamma. This is a angle sum rule. If you remember, cosine say capital A plus B, angle equals to cosine A times cosine B minus sine A times sine capital B here. Okay, so you can compute this. I mean, this is same as cosine negative cosine pi over 3 times cosine gamma plus sine pi over 3 times sine gamma. And we do know the value of sine gamma here, sine gamma. And the cosine gamma is nothing but, because this is acute angle, the cosine gamma is positive, so 1 minus square of sine gamma. Okay, so you can have a specific value here. If you compute this one, you will get, if you compute this one, you will get 1 over square root of 13 here, square root of 13, so they are cancelled out, and the value of length of side AC square is 9 plus 13 minus 6, which is 16. So length of side AC will be 4 here. So we extracted another length of the side AC, which is 4. And let me go a little bit further. To figure out the radius of the circumscribed circle of the triangle ACD, to figure out value of capital R, use the law of sines here. It's actually the diameter, the value of diameter is the same as 4 over sine of its opposite angle, sine capital D. This angle ADC, I just denote it as capital D here. And with this property here, we can switch sine D to sine B times certain vector here. So if you use this property, this is 5 over 6 times S sub 1, which is 3/2 times square root of 13 times sine of capital B here. So it's a little bit messy, but you can switch capital D, sine of capital D, as 2 over 9 times 5 over 6 times 3 times square root of 13 over 2 times sine of capital B. Okay, so if you switch this sine of capital D with the value of sine of capital B times inverse of this. Let me call it. You can compute this value as like I want to denote it as a star. So 1 over star. And as you already know, by the law of sines for the triangle A, B, and C here, so 4 and its opposite angle, capital B, this value is the diameter of the circumscribed circle, this one, which is square root of 13 times 2 over square root of 3. So this 1 over star, if I compute, and then 9 over 2, 6 over 5, 2 over 3 times square root of 13 here. So square root of 13 are cancelled. This is also cancelled. It's good. And what I have, the 3 can be factored out. So I have the value 1836 over 5 times square root of 3 here. So anyhow, you get the value of capital R as 18 over 5 times square root of 3. Okay, so let me give you a last punch, counter punch here. So we do know the length of side AC and the radius of the circle 18 over 5 times square root of 3. So if you combine those two values, and then you can get this value, because this value is nothing but sine angle ADC. I denote it as a capital D, 4 over sine of capital D times R over 4. I deliberately expressed this 4 because I want to use the law of sines. It's a recycle here. So I care for the environment here. It's actually capital R square over 2. Okay, and you can compute this value. Okay, let me wrap up this problem. My talk became a little bit lengthy here because I don't want it, but I had to use 3 formulas here, the angle sum of cosine in case of cosine. On this one problem, this is one problem, a single problem, but so many ingredients are in it. So if you don't taste each ingredient, it takes time. You cannot taste the full flavor of this problem. So this is why the single problem can be complicated enough as a one problem, but I choose this problem to review because um, it has um, say kind of deep meaning inside. Okay, that's it.